All right, hello and welcome to today's presentation, Our Water Preventing Pollution. My name is Samantha Gentry and I'm an AmeriCorps member serving with Conservation Nebraska's Common Ground program. Conservation Nebraska's mission is to protect our state's natural legacy by educating the public, supporting communities, and increasing civic engagement, which we accomplish through locally led education efforts and community engagement projects to address conservation concerns. Before the presentation, there are a few housekeeping things to go over. For those online, your cameras will remain off and you will be muted throughout the presentation. Please type any questions you have into the chat or the Q&A section, and we will answer those at the end of the presentation. For those in person, please feel free to raise your hand when you have a question. Some questions may have to wait to the end of the presentation due to time constraints. This presentation will be recorded and will be uploaded to Conservation Nebraska's YouTube page within the next couple weeks. So if you miss any part of today's presentation, would like to revisit any part, you will be able to find it there. Following the presentation, we will have a very brief survey that should only take less than a minute to complete, both online and in person. This survey helps support programming like this one, so we appreciate you taking the time to fill those out. If anyone is interested in speaking with a Conservation Nebraska member regarding conservation issues in Nebraska, or to find out more about what we do, please contact us at info@neconserve.org. I would like to introduce our first speaker, who is going to speak to us about our water preventing pollution. Erin Kubicek holds a BA in biology and an MS in natural resources, specializing in human dimensions. As the Senior Environmental Health Educator for the Lincoln Transportation and Utilities Department Watershed Management Division, she has more than a decade of experience in rainscaping and green infrastructure. Erin is passionate about helping communities understand pollution prevention, and water quality, and manages a cost share program that supports homeowners in installing rain gardens. Please join me in welcoming our speaker.
Okay, well, thank you. As she said, my name is Erin Kubicek, and my presentation is on sustainable landscapes and other things that you can do in your own yard to improve water quality. In case you don't know, watershed management is a division of transportation and utilities. We are responsible for managing stormwater, reducing flood hazards, and improving water quality of stormwater runoff. One thing that we talk about a lot is what is a watershed? So I have a graphic here that just kind of shows a watershed, and it shows it's an area of land that drains to a common water body. And it's helpful to remind people that we all live in a watershed, and so we're all connected in that way. Something that happens upstream can affect those that are downstream.
Somebody online said they can't hear you.
Oh, I don't know.
I'm just going to make sure really quick. Can someone give a thumbs up if they can hear us? Oh, it looks like it might be better now.
Okay.
Okay, sorry to interrupt you.
No, that's okay. Sometimes there's technical difficulties. This graphic here just shows watershed hydrology and how it changes before and after development. So as Lincoln grows, we transition away from the graphic on the left towards the one on the right, where you have a natural area like a forest or a prairie. You'll see that there's very little runoff and a lot of infiltration. Whereas when you have a urban area with lots of hard surfaces, then there's lots of runoff and very little infiltration. Which brings us to water pollution. We talk a lot about impaired water bodies, and an impaired water body is one that does not meet water quality standards due to the recurring presence of one or more pollutants. The Nebraska Department of Water, Energy, and Environment now currently monitors 13 water bodies in the city of Lincoln, and approximately 77% are classified as impaired. Now, this is an old map on here, so there's a couple of water bodies that are missing, but you should be familiar with some of these. Salt Creek is the big creek that runs through the middle of Lincoln, and then a lot of tributaries are impaired, like Antelope Creek and Beal Slough, Oak Creek. And Holmes Lake is on there, and Oak Lake. Missing from the map is Dead Man's Run and Bowling Lake, which is up by Air Park. They're impaired for different reasons, and not all of the reasons are ones that we have entire control over. For a long time, the EPA kept asking us, what are you guys doing about your chloride problem? What chloride problem? It's Salt Creek. It's called that for a reason, right? But they just look at, the numbers, and so they kept classifying certain streams as being impaired for chlorides. Other things like Holmes Lake, one of the impairments is nitrogen. Isotope tracing told us that up to 30% of that is actually atmospheric deposition. It's not all bad news, though. I mean, I don't know if anybody remembers in 2018, Antelope Creek, it's still impaired, but it was delisted for E. coli, which is huge. They do not delist things very often, and it's very difficult to get something, especially an urban stream that's impaired for E. coli, delisted. I think it's only happened like a handful of times. So it was a huge deal. They had a big press conference, so you might remember it. In 2018, we had a press conference at Union Plaza about it. So where does all this water pollution come from? And it's a common misconception that most water pollution comes from industries. But there's that thing called the Clean Water Act, and they have regulations, and industries have to get a permit in order to discharge, and they have different benchmarks that they have to meet. And so this was put into place in order to regulate point source pollution, which is basically just water coming from an identifiable source. So I can point at that pipe and say, there's pollution coming out of there. The truth is, though, 70% of water pollution actually is non-point source. It's coming from everywhere. Stormwater runoff is carrying fertilizers, garden chemicals, pet waste, automotive chemicals like oil and antifreeze, and also debris, including yard waste. And it picks all of that up and carries it with it into the storm drain system. And where do storm drains go? They go directly to the nearest water body. So that can be a stream or a lake or a wetland. To address this, they now have the Water Quality Act, which was in 1987, and federal law requires that municipal separate storm sewer systems, or MS4s, obtain permits to regulate non-point source pollution. The city of Lincoln obtained its permit in 2002. And the permit covers a whole bunch of different things, everything from public education to illicit discharge detection to good housekeeping, all sorts of different things that we have to meet. Some of the things that the city of Lincoln is doing is a lot of water quality projects. And you may have noticed them walking around town. You may not. Some of them are more obvious than others. In the pictures here, I have the top one is the wetland at Peterson Park. And then below it are some bioretention cells that are on Centennial Mall. And you can see the curb cut there in the middle. So that's taking in stormwater off of the street. And then the cute little mini street sweeper that Watershed purchased for Downtown Lincoln Association so they can get into all the nooks and crannies downtown where the regular street sweepers can't get to. So then this part of the presentation then comes to what can you do as a homeowner or Lincoln resident to help? There are sustainable landscapes for homeowners. Popular ones are rain gardens, native landscaping, just having lots of deep rooting plants, soil quality restoration, water-wise lawns like buffalo grass, removing unwanted pavement, having permeable paving, and rain barrels, which are very popular in Lincoln. So the two most common water quality projects that we'll talk about today are rain barrels and rain gardens. And then one underappreciated project is a soil quality restoration. And then we'll talk a little bit about lawn care too. So a rain barrel, in case you're not familiar, is any above ground container that's modified to collect, store, and distribute rooftop runoff for non-drinking uses. And rain barrels are usually 55 gallons in size, but they can be smaller or larger. There's a lot of benefits to rain barrels. The water is naturally soft. There's no chlorine, fluoride, salts in it. You can save water for dry spells, which is usually what most people are interested in. But they also reduce runoff and stormwater pollution because you're capturing that water and you're holding it there and preventing it from leaving your property. Rainwater can be used for watering your lawn or washing your car or bicycle. And if you have multiple rain barrels, you can actually save quite a bit of water over the summer months. Watershed does have rain barrel classes at SCC. It's now called the Community Education courses. It used to be called Continuing Education. And the tuition for that covers a rain barrel that you take home. And you actually register through SCC's website for that, but I'm the one who's teaching the course. The other popular project is rain gardens. And that one is a garden that's planted in a small depression, and you'll have native shrubs or perennials, and it's usually formed on a gentle slope and strategically placed so that water from a rooftop, so like you point your gutter there, water flows off of the roof and into this garden. And a rain garden is more of a water quality feature, but it also has a lot of other benefits. But it's designed to capture that stormwater and give it time to soak into the ground naturally instead of running off of your property. Benefits include they improve water quality by filtering out the pollutants at the source. They decrease water pollution from your property by up to 90%. They can provide localized stormwater control. They're easy to maintain and requires less watering after they're established. And they can also provide habitat for birds and pollinators, which a lot of people are very interested in now with, wanting to promote bees and butterflies. And a lot of native plants are good for rain gardens. We're trying out a rain garden class this year at SCC. We have not had a rain garden class in probably 12 years. So this is a new one, and this one you will get a rain garden plant kit that you can take home. Less thought about as a water quality project is soil quality restoration. So the soil in Lincoln is generally low in organic matter, high in clay, and this is particularly true in newer neighborhoods where that topsoil just got scraped off and taken elsewhere. And then they just come and slop sod down on top of the yucky clay that was underneath. Compost actually holds approximately 20 times its weight in water. And so it makes a really good soil amendment that can actually be spread over the top of the lawn as a top dressing. So by adding compost can actually help improve water quality because you're adding organic matter, which allows more water to soak in, reducing stormwater runoff. And if you have more organic matter in your soil, then you should need less fertilizer. And I have a picture of them dumping out compost into piles, and then they go around and they actually rake it in. So then, and sometimes they'll overseed it, but you don't have to. And then that is a picture of, on the left is a lawn that did not have a top dressing done, and the one on the right had the top dressing done. And that's like at a townhouse, so it's kind of a nice direct comparison. Anything else? Well, we'll talk a little bit about lawn care. We do promote lake-friendly fertilizer, or fertilizer that does not contain phosphorus. It's a lot easier to find now. It used to be fertilizer just had phosphorus in it. But most soils in Lincoln contain more than enough phosphorus. And the soil can only hold so much. And so if you just keep adding more phosphorus on top of it, it's not actually going to go into the soil. It's just going to kind of sit there. And then when it rains, it'll just get carried off. 1 pound of phosphorus can produce over 300 pounds of blue-green algae, although I've seen other estimates, more or less. You can also use a mulching mower. So bagging your grass clippings instead is going to rob your lawn of nutrients. So instead, if you mulch the clippings, you can actually provide an equivalent of 1 regular fertilizer application over the course of a year. And if you're really brave, you can skip the fertilizer altogether. Lawns need much less fertilizer than is advertised. And if you still want to apply fertilizer, we suggest getting a soil test to see what you actually need, and then just only applying that instead of just blanket applying fertilizer. And then when you mow, maintain a higher mowing height, because the root depth is actually directly proportional to how high the grass is. And by doing this, you're going to make the lawn more drought tolerant, and also allow more water to soak in, because those deep roots are helping break up the soil. And then also, don't be like this person here. Sweep up your grass clippings, or you can use a leaf blower. Get them back up onto your lawn. Don't leave them on hard surfaces, because when it rains, that will actually get carried into the storm drain. And when the grass clippings decompose, then they release nutrients into the water. That was all I had. There's my contact information if anyone is interested. And also, please pick up after your pet.
I have a question.
Sure.
So why did it take so long for Lincoln to get the permit for the water quality law since it started in 1987?
They did not actually start doing permits until after the 1990 census. And so our permit is actually based on that census. But yeah, it took a while to get all of the stuff lined up and ready to go for the permit. So there was like a lot of like prerequisites of stuff that we had to have in place before we could actually apply for the permit and say we're going to do X, Y, and Z.
Thank you.
Yeah.
When is the rain garden class? Like, when does it start?
The rain garden class is in April. I believe it's the 28th, April 28th. It's just a 1-day, 1-evening class. So yeah, you just come and learn about how to install a rain garden, and then you get a plant kit. Yes.
For the rain barrel, I would vary with the size of the house, but came 1 barrel. any tree to fill up?
It'll fill up, yes. That's why you have an overflow. And there's a couple ways of going about it. You can either have a separate overflow, or you can have a closed system where there's actually just this tube that goes directly from the downspout over to the barrel, and it's sealed so that when the barrel is full, it just backs up, and then just the water just keeps going down the downspout. So there's more than one way to do it. Makes sense.
Is runoff from the shingles like on the roof, is that bad for plants? Like I'm just thinking of the rain garden with like the
It's not bad for plants necessarily, no. The question comes up a lot during the rain barrel class, because a lot of people want to use the water to water their vegetable garden.
Yeah.
And the water can be considerably polluted on coming off of the roof, but it also depends on what the shingles are made out of. And if you have birds and other animals that are hanging out up there. And so there's actually been a lot of studies done where they were actually creating pollution and testing it coming off of different types of shingles. So it's actually a very interesting rabbit hole to go down. But yes, the water is certainly not clean, if that's your question. Yes, but it doesn't necessarily hurt the plants. The plants are actually very good about removing those pollutants.
Like it's a comment question online.
Oh.
So
Okay, we have a question online. We run a community garden in Omaha, and we're wondering if it would be beneficial to divert rainwater running down our hill during storms to lift it off our pollinator garden. Oh, lift it onto our pollinator garden. Do you have any thoughts on this? We have a huge pollinator garden next to the street, and keeping it watered is challenging.
Okay. I've seen some very creative uses of grading and directing of water. So that certainly could be a possibility if if things are positioned in an advantageous way to get the water from point A to point B. I have seen some very interesting and creative uses of grading to direct water and then have it meander through like a garden area.
Okay, and then I'm just gonna check. All right, no questions in the Q&A.
Okay.
All right, thank you. All right, our next speaker is Anni Poetzl. She is the statewide University of Nebraska Lincoln Extension Educator for water quality. She received her master's in natural resources from UNL and her undergraduate degrees in English literature and conservation biology and ecology from Arizona State University. Please join me in welcoming our next speaker.
hi everyone. My name is Anni Poetzl. As mentioned, I'm the statewide water quality extension educator. And today I'm going to be presenting from leaky to squeaky, clean agricultural systems, and presenting some of the work that's done by pretty much all of the team that's shown here. So we have project leaders for the high clearance cover crop interseeding project, which is Victor. He's our PhD student. But then there's Chris and John, the co-leads, and then our extension teammates out on the county level. I'm going to kind of run through kind of cover crops, watersheds, talk about our project, and then talk about drinking water and the importance of getting our drinking water tested, depending on kind of where your source is from. So Erin did a wonderful job describing what is a watershed. I'm glad we were on that same wavelength. So I won't indulge too much on that, except I will kind of define what I mean by a leaky system. So leaky, it may bring an image to mind, but in this sense, how I'm talking about it is really where external inputs are greater than what's coming off of the land. There was a study done in 2021 with NRDs and UNL, where they were looking at in a specific area with a couple NRDs about, a partial nitrogen balance and looking at what were the inputs going into the system, fertilizers, and then the outputs coming out of the system. And that was in the form of the grain yield and how much nitrogen it had in it. From that, 70% of producers had a surplus and balance, which really kind of indicated that although some producers are really getting into nutrient management and nitrogen management, there's still much that we can do. And this is important in the watershed context because, as Erin had mentioned, water can flow over the land in runoff, stormwater runoff, irrigation runoff, but can also percolate down into the groundwater. And in terms of drinking water, 88% of Nebraskans rely on groundwater as their primary source of drinking water. And to kind of further look at this, the Department of Water, Energy, and Environment, formerly the Department of Energy and Environment, or Environment and Energy, wow, what a mouthful. They had conducted a study from basically 2023, 2024. It was really a sampling initiative for private domestic well owners across the state. 3,478 participated, and these are all the different points and the range of concentrations. From this, the red points, especially the bold red, is above 10 milligrams per liter, which is above the maximum contaminant level for nitrate established by the Safe Drinking Water Act, which is a federal regulation, but it's also within the Title 179, which is a Nebraska regulation. So really, when things exceed that maximum contaminant level, it means that it poses a health risk to vulnerable populations and can occur in a short amount of time. So if you guys have ever heard of blue baby syndrome, that is one of the effects of being over 10 milligrams per liter. And really what it does is it messes with the body's ability, the cell's ability to transport nitrate or oxygen because of the high levels of nitrate. Sorry. Oh.
Someone said that they can't see the screen.
Oh no.
I just want to make sure. This one.
Oh.
Okay.
Thank you.
Make sure. Yeah.
Thanks. So it really just shows kind of the distribution and areas that may be of concern when there's leaky agricultural systems and leaky activities on the landscape. So what's being done to make agricultural systems less leaky? Well, there's a lot of tools in the toolbox, so to speak, or best management practices that can help reduce the amount of nitrates that leave the system or different nutrients. And one of those is cover crops. So cover crops have many different benefits. One being their ability to scavenge up excess nutrients and kind of use it for their own growth or incorporate and assimilate it into their biomass. They could be good at suppressing weed growth. If they're in the bean and legume family especially, they're known for being nitrogen fixers, which can help kind of different forms of nitrogen be more accessible to plants, so converting it into nitrates. And then also, we have their ability to basically kind of keep in soil moisture and help water kind of infiltrate the soil more just due to their roots, and they have just a lot of benefits. And when thinking about nutrient management, you may have heard the 4 R's, which is right source, right method, right rate, right time. This kind of figure graphic shows also assessment being one of those, and it creates the word SMART. So thinking smart, being smart, doing smart. And assessments really allow people to respond to the needs of the system by having that baseline. So they know where it's starting at and can apply, then kind of responding to that instead of just doing a lump sum of a lot of fertilizer. Which brings us to the high clearance cover crop interseeding project. So as mentioned, this was kind of done by my predecessors in my team prior to being in this position, but it has a lot of really interesting results that I wanted to share. So this is our high clearance tractor, and on it is this 105-foot wide beam. That is our cover crop interseeder. It's our toolbar. And it has these black lines going across it that are basically kind of these tubes that help distribute the cover crop seeds. It has the ability to have these drop-down tubes so that when interseeded with corn, that's like a stand of corn, it's at the R5 stage, it can actually go underneath the corn stand or like the corn canopy and distribute the seeds. So the R5 corn is on kind of the smaller picture to the left, and then on the right is kind of where the seeds are all kind of distributed. I have those two little figures of the drone and the drill to remind myself and to tell you all that there are different ways to basically incorporate cover crops into systems. Our high boy is one way, this high clearance tractor, but there is a drone or aerial broadcasting with planes and a drill. So there's a couple different options, but we're focusing on this high clearance tractor. We kind of had two main objectives of this project. So the first one was to establish one-year sites. It kind of was to promote just rapid adoption of cover crop interseeding, potentially using this high clearance tractor as that method for distributing the cover crop seeds. And throughout 2022 to 2025, the course of the project, we were at 62 different sites, and we collected cover crop biomass and soil nitrate content. And even after a year, there was some results that were favorable and that may incentivize people to continue more of a long-term adoption. So the figure that we have at the top shows fall 2023, spring 2024. Cover crops were planted fall 2023. This sample was taken after the corn harvest. So that's kind of like the beginning, so to speak. And then spring 2024 is closer towards when cover crops would be terminated. And it shows that the orange being the no cover crop field strips and the green being the cover crop field strips, kind of the difference between the soil nitrate content as you go deeper into the soil profile. So at the top, you have 12 inches in depth of the soil profile down to 36 inches. And in spring 2024, there's a significant difference between basically 0 to 12 inches within the soil profile. So we felt like that was pretty exciting to share with our one-year producers. But then also at the bottom, we have a table that just really kind of completes the picture of, you know, as these cover crops are growing, they're assimilating the different nutrients, and nitrate is one of those. So showing that that growth did occur. Because this was more to try and get people thinking about cover crops, to get people thinking about the methodology of using this high clearance tractor, we also wanted to get some impressions from producers. So this is informal. We're hoping in the next stage that we can collect a more formalized process of getting these, you know, attitudes, feelings. But really the main takeaway was from people who liked the tool, liked the results. One of the major setbacks for the methodology in itself was investing money into the single purpose toolbar. So in the future, I think we would like to explore that, and I'll expand on that a little bit. The second objective of our study was to establish 3-year sites, and our 3-year sites were meant for long-term data collection, and also to collect more rigorous samples. So we didn't just collect cover crop biomass or soil nitrate content. We also collected the succeeding crop yields to see if there was any penalty after growing cover crops, some satellite imagery, and weed suppression. And these occurred on irrigated and dryland sites throughout kind of eastern Nebraska. From this, and when talking to my team, my understanding is that all 3-year sites, all 13 of them, they didn't see any significant penalties to crop yield. Like, regardless of having cover crops or none, crop yield was the same. So that was great to hear. Some project conclusions is that really that cover crops can be a great tool in the toolbox related to water management, nutrient management, and facilitating soil health. But we know that there's much work that's being done by producer communities. We've worked with many of them, and none of this work could have happened without them. But we also know that there's room for improvement, and this could be a tool in the toolbox that's perfect for somebody's needs. So we want to amplify it out. Some next steps, as mentioned, was kind of creating these producer networks. So looking at people who have invested in these tools and trying to get them together to talk about the pros, the cons, how they've made their operations successful, and really kind of building that group and that camaraderie. We also have the economic analysis portion that we would do, which has to do with more so seeing what are different scenarios in which this tool could be economically feasible. And if not, maybe looking to different groups like commercial service providers and being able to show these scenarios where they have maybe more money at hand than producers and would be able to potentially rent it out or something. So these are just ideas, but I think these would be our next steps. So knowing that cover crops can capture or scavenge excess nitrate, we talked about how water moves across the watershed, how it can go into the groundwater, how it can run off into the surface water, and how Nebraskans, 88% have groundwater as their primary drinking water source. So you may be wondering, well, where do I even start? Where do I see test results? Should I get my own test results? Well, it kind of just depends on what is your drinking water source. And by this, I mean, do you fall under a public water system, or are you a private domestic well owner? So public water systems are basically divided into 3 subcategories. Since I'm in Lincoln today, I'll really emphasize that they are within a community water system. But there are other examples that I won't dive into just due to time. But we also know that the private domestic well owners also have their specific wells that they're getting water from, and we recommend testing them. So I'm going to show public water systems where they can go to look at their test results for their systems and identify those. And then I'll talk a little bit more for private domestic well owners. So for public water system users, you can go to drinkingwater.ne.gov. Drinking water is one word. And for me, I'm a very visual person. Plus, I don't know all the parameters of my public water supply system. So I go down to click here for the county map of Nebraska. Then, because I'm in Lincoln today, we'd go to Lancaster County, and it would propagate this huge list, but I'm looking for our community water system, so City of Lincoln. And then when I click that, it shows all of the information for current water operators, how to contact them, phone, email, all these things. But also on the left-hand side, it includes other options. And the one that I'll kind of steer us towards today is the violations/enforcement actions, just because that's when, if any contaminant in the drinking water standards, the Safe Drinking Water Act, if they are exceeded, that's considered a violation. So the systems have to act on that. So it's good to know and kind of understand, what's going on. So when we go to the City of Lincoln, they haven't had any violations since 2004, and it looks like it came from total coliform. But if we were to click into the violation number, it shows kind of where that system is in the process of addressing and getting back into compliance. So it's just one of the tools that you can use to really figure out, what's happening with my system. Talking to your water operators if you have questions is always a great idea. They will be able to know in and out what's going on. But yeah, this is one of the ways you can see the results. And then as a private domestic well owner, it really falls on the owner themselves to do the testing of their wells, just because they are not regulated federally or on the state side for their drinking water. So what we recommend is to test nitrate and E. coli annually, just because those pollutants can have different sources, they can change more. So we recommend getting them tested annually. But then we recommend testing at least once for kind of regionally and naturally occurring contaminants, such as arsenic, selenium, uranium, iron, manganese. And a really good resource for understanding what may be applicable for testing at least once is natural resource districts, because they manage the groundwater for quantity and quality at a local level on the kind of that watershed level. So they'd be able to really help you kind of understand. Because what I didn't mention is that public water systems, they test for 90 plus contaminants annually. So if there's a way to target test for people who are paying out of their own pocket, that is a really good way. Also, some NRDs have like test nights and other ways that it's good to check in with them. Some other things that you can do is keep accurate well maintenance records, make sure wells are registered, properly close unused wells, avoid using potential contaminants near the wells, because wells are like a pipe. So if you use a contaminant and it falls into the well, it kind of can go just straight down. Pump and inspect your septic systems as recommended by your local health departments and the manufacturer's guidelines. And I threw a lot at you, but what's important to know is like you're not in it alone. And there's a lot of people that's working on water management, water research, different aspects of water throughout the state. And this is definitely not an exhaustive list, but on the left-hand side, we have different state agencies that are working in the realm of water quantity and quality management. So Department of Water, Energy and Environment, Department of Agriculture, our natural resource districts, Nebraska Game and Parks, but also different institutions and organizations like University of Nebraska Systems in Lincoln, Omaha, the Medical Center, Doherty Water for Food, Nebraska Water Center, and so many more. So with that, thank you, and I'll take any questions.
I have a question.
Yeah.
If there is a violation that gets marked on that website, does that get publicized? Like, are they required to let the public know that?
Yes, and there is a process. Unfortunately, I don't know all the process, but I do know that they have to publicize it. So you wouldn't be ignorant to something that could cause like a health drinking water concern, but that's a great question.
Okay. And then I have another question too.
Yeah.
Do like refrigerator water filters or Brita filters filter out those contaminants that you were talking about?
I don't think refrigerator ones do. I know Brita can help with some, but I'd say the most effective like tool to use is actually reverse osmosis systems. And what that entails, I know that it can be kind of a hefty sum. So right now, the Department of Revenue has a tax credit program to help people kind of get those systems if they need it. So yeah.
See if there's any questions in the chat.
I was going to ask, do you know if the, because I know the NRD does test your well nights, do they give like recommendations then to people on what should be installing?
I'd imagine that they would be able to help follow up and really help them kind of look at their test results and kind of understand what additional steps they might take. I feel like they are probably really good at that, but I've never been to one to confirm one, but I'm pretty sure that they'd be helping people kind of get where they need to. But that's a great question. Thanks.
And I don't
Any
see
online?
any questions in the chat, but we will leave the chat open. So,
Okay. Well,
all
thank you
right,
guys.
thank you. Okay, our last speaker tonight is Dr. Steve Comfort. He is a soil and water chemist and professor in the School of Natural Resources. He is a member of the environmental science faculty in the School of Natural Resources and contributes to the environmental science major at UNL. His interests are in understanding the fate and transport of organic chemicals in the environment and devising remediation strategies for contaminated soil and water. Most recently, he has been working on methods to improve water quality in urban ponds. So please join me in welcoming Dr. Comfort.
Okay, thank you, Samantha, and thank you all for the opportunity to speak today. I'm Steve Comfort, and I'm going to talk about restoring water quality in eutrophic ponds or ponds that have a bunch of algae and weeds in them. I'll begin with a short outline to tell you what I'm going to talk about. I don't work alone, so I want to tell you who we are, what's the problem that we're working on, what is our approach to treating the problem, and then give you some field results. Okay. So to begin then, I'm Steve Comfort. I'm a professor of soil water chemistry. I've actually been at UNL for 34 years, and I'll be retiring this June. If I had to put a thread through the type of research that I've been doing, it's something dealing with remediating contaminated environments. I started out when I first got here treating contaminated soils. I did that for about 10 years. Then we switched over to treating contaminated groundwater. We did that for about 20 years. And then lastly, for the last part of my career, I devoted it to trying to clean up algae weed-filled ponds. So with regard to that, I work with Dr. Erin Kubicek. She's a professor in biosystems engineering. And he and I together got a grant from the state called a Biological and Chemical Approach to Restoring Eutrophic Ponds in the Lower Platte South NRD. So with this funding, we've treated about 8 ponds. 7 of them are in Lincoln, and 1 of them is out in Kearney. Together, we've advised 3 graduate students on this project, and we've also used many undergraduate students to help us construct these floating wetlands and to sample the ponds over time and do the chemical analysis. So, what is it we're doing? What's the problem? Well, if you were to go up to Wisconsin, where I'm going to retire, go to northern Wisconsin, northern Minnesota, Canada, you'd see these crystal clear ponds or lakes. But if you drove around Lincoln in the summer, it wouldn't be unusual to see ones that look like that. So what's the difference? Why? If you were to take a introductory soils class or a plant science class or an agronomy class, one of those classes would teach you what's called Liebig's law of the minimum. And that was a soil chemist who came up with the notion that plants need 17 nutrients to grow. But what he said is that the amount of growth that occurs is not dictated by the nutrients in most excess. Rather, it's dictated by those that are limiting. And to make that point, he came up with this barrel that had different length planks on it, which are called staves. And he said the barrel can only hold as much water as the lowest stave. And plants, including algae and weeds, are controlled by that. And actually, most surface waters are considered either phosphorus limiting or nitrogen limiting, meaning if you're below this threshold value, you won't get weeds and algae. But if you get above that, you do. And a famous study in Canada in the 70s divided a lake in half. They added nitrogen and carbon to one side, nitrogen, carbon, and phosphorus to the other side, and you can see the stark difference. The added phosphorus spurred the growth. So eutrophication then is simply the process by which surface water becomes progressively enriched with nutrients like nitrogen and phosphorus. And when you have that, you have excess weeds, algal growth, you get low oxygen, which leads to fish kills, and then harmful algal blooms. And when we're dealing with urban areas, right, as Ms. Erin very thoughtfully told us, we get runoff, right? We have impervious surfaces, and that water has to go somewhere. In urban areas, that water is directed to sewers, which then go to stormwater retention ponds. Water is considered the universal solvent, so anything that goes over, it can dissolve and carry those nutrients to these ponds. And if your pond looks like that, what can you do? What are your options? Basically, you have four. The first one is do nothing and hope that the situation improves. That's unlikely to happen. Very unlikely to happen, and I'll explain why in a slide or two. Your second is to do some of the things that Anni and Erin suggest. You implement preventive measures to reduce runoff, right? Try to make not try to get it so the problem doesn't get any worse. Your third option is to hire a commercial vendor to come out and use pesticides, herbicides for weeds, algicides for algae. That'll work. That will remove them from the pond, but that's treating the symptom of the problem. The problem is excess nutrients. The symptom is the weeds and the algae. So when you treat those with pesticides, you're not getting at the problem. And then your fourth option is to try to reduce the nutrients in the pond such that they're limiting again. They're below that threshold where weeds and algae cannot grow. So you're actually trying to reverse eutrophication. So the question is, can you do that? Is that possible? It is, but it takes time, years, and diligence. But that's the approach we took. I won't go more into this other than there are preventive ways to do things. The pond on the right is in Lincoln. You probably know that geese can make a mess. If you have a big buffer strip like that, there's no geese in that pond because they're afraid of predators. So they've avoided that by having a large buffer strip. Phosphorus-free fertilizer should be used. Get homeowners to pick up their waste, dog waste. All those things can help make the problem not get any worse. But let's look at what happens. If external runoff brings in nutrients, okay, and just for the sake of argument, let's say, all right, we're going to stop that. We're going to prevent that from happening by our watershed management practices. The problem is that the nutrients are already in the pond, and the nutrients allow plants and algae to grow. And over the season, eventually they're going to die, and then they're going to sink to the bottom, and then the microbes are going to decompose them and re-release the nutrients the following year. So that's how you get this internal cycling of nitrogen and phosphorus in your pond year after year. That's why the problem will not go away on its own. You need something active to remove the nutrients. So that's the approach that we've taken. We've taken a biological and a chemical approach, and I want to show you how it works. The pictures on the right are the Cooper YMCA pond. When we started working on that pond, it was like a green carpet of algae. But over time, using these treatments I'm going to tell you about, eventually we could improve the water quality of that pond. All right, so the biological approach uses floating treatment wetlands. What are those? Floating mat, they're 20 feet by 20 feet. They got 1,000 plants in them. The roots dangle into the water, so the plants can take up nitrogen and phosphorus. That's one way. But their biggest contribution is what happens down in the root zone. The roots release carbon. The microbes on those roots want to eat that carbon, and in the process, they can convert nitrate to nitrogen gas, which goes up to the atmosphere. And that's how they work. And maybe you're thinking, well, how much can they remove? That would be a logical thing to ask. So one of my very last graduate students, Jenna McCoy, is standing in that pond, happy. She looks happy. We put pool liners underneath these wetlands, and we spiked them with nitrate. And then we measured how fast the nitrate went away. And what we found is that for 2 floating wetlands, 20 feet by 20 feet, we can remove between 1.4 and 4 pounds of nitrogen over a growing season. And that is significant enough to reduce the nitrate in a 1 to 2 acre pond. Okay, what about the phosphorus? Because you want to get that out too. So that's where we use a chemical approach. We use the chemical called lanthanum. That's a rare earth element. It wants to bind with phosphate very, very strongly. When it forms lanthanum phosphate, it becomes very insoluble, that the plants can't use it, weeds can't use it, algae can't use it. It just goes to the bottom of the pond, and that's where it sits. We made these composites that are made out of lanthanum, wax, and sand. We put them in an airlift pump. We aerate underneath them, and then we get this kind of ring of waves coming out of this airlift pump, which disperses the lanthanum out into the water. So this works great, but there's a problem. The problem is that the lanthanum composites were developed in my lab, and they're not commercially available. Secondly, these airlift pumps were also made by us, and those are also not commercially available. So to try to adapt what we've done and learned, we changed it a little bit. And we started using alum, which is available and much cheaper than lanthanum. You can mix that with water, and we can pump that to an airlift pump, or we could pump it to a fountain, which many homeowners associations have, and slowly drip the alum into that fountain to spread it out over the pond. How well does it work? These are results from the Cooper Y, where we were using mainly lanthanum. I'm graphing 4 years of data, phosphate, nitrate, and dissolved oxygen. So we want the phosphate to be 0.02, around 0.02 or less. That would be the critical value. We want to get below that. Algae and weeds won't grow. You can see it was much higher than that when we started, but eventually it came down. Nitrate as well came down from the floating treatment wetlands. And when you remove nitrate and phosphate, the clarity of the water improved dramatically, and sunlight could penetrate into that water. And when that happens, we get photosynthesis of the plants that are in the water. And when photosynthesis of the plants occurs, they release oxygen. So higher oxygen is a really good indicator of water quality health, because the more oxygen that's there, the greater the ability for the microbes in the water to consume all the dead material, the leaves that fall in, roots, whatever. High oxygen allows them to consume it and convert that dead material to carbon dioxide. But if water's not clear, or if you're using a pesticide that kills all plants, which some people do, you're not going to have high oxygen in the water, and you're going to have this situation where you have anaerobic conditions. These anaerobes, they want to eat the carbon too, but there's no oxygen. They can't use oxygen. They use something else. They produce hydrogen sulfide, or the swamp smelly gas that you smell. That's done by anaerobes. And then you get this black muck building up at the bottom of your pond. And those are nutrients in there. And you're not going to improve water quality if you have a lot of this in the bottom of your pond. On the right, it shows a little experiment we did where we put maple leaves in mesh bags, put it in a high water clarity pond versus low. And you can see that the low water clarity got dark, and it's on its way to becoming this black muck. Okay. Another thing our grant allowed us to do is to go out to these ponds and tell the homeowners just how much muck they have. We have a pole that's got metrics on it. We go out with a kayak, we push down till we hear some resistance, then we push further, and that difference tells us how much muck is there, and then we can make a map of the muck for the individual ponds. And over time, if you have the patience and dissolved oxygen stays high, this can be decreased. So lastly, we're coming out with an extension circular. It's kind of like in the copy editor stage right now. I would think within just a couple weeks, it'll be able to download it from the Nebraska Extension Publication Office, titled Restoring Water Quality in Eutrophic Pond. It's much more detailed than what I just gave you. So with that, thanks for your attention. And if there's any questions, I'll try to answer them.
I'm also gonna launch the Q&A or launch the survey real quick on here. But yeah, feel free to answer questions while I launch the survey.
Well, mine was super to a slide, but the slide that had the three graphs of the phosphorus, nitrate, and the dissolved oxygen.
Correct.
On the first one, the last dots, it looked like the phosphorus I mean, it's already low, but
Yeah, I mean, we're going to get variations with incoming runoff. Maybe that was right after a rain event or something like that. So it's not going to always stay down. We're just going to try to keep it low.
so that may have more been a singular event.
Right.
Rather
The
than,
trend is that it was
Yeah,
coming down
yeah.
over the 3 years,
That's
4
why it
years.
stuck out.
Yeah. Yeah.
Is the compound created like by phosphate or by phosphate? Does that impact the water at all, or does it like sit on the bottom like?
So it becomes very, very insoluble, that it's no longer available to plants or algae. Can you show that slide? Some people are concerned about, what does the lanthanum do to the water quality? And actually had an undergrad's grandma ask that question, and we turned it into a project. Yeah, where we harvested fish over time and determined the amount of lanthanum that was in the liver of the fish, and we had no significant increases over this pond versus one where lanthanum was not used. But this is before lanthanum. You can see how the water clarity improves after we used it.
For the wetlands, how practical is that for someone to maybe do
So I think that's doable. There's got to be people around the HOA that have green thumbs that want to grow plants. We bought the plants from the Arboretum, which is now called Plant Nebraska. Each plant was $350, and the mat was, so it's about a $7,000 investment for a 20 by 20 foot floating wetland. And then the fence that's around it, we build ourselves, because if you don't have that and there's geese there, they'll come and eat all the plants before they get established. So that part is doable.
And then I guess I just have like a general question. So how do you work with like the city of Lincoln and the extension office? Like what does your work entail with them?
There hasn't been a lot of interaction. I've actually looked for avenues like venues like this to speak at, and I just couldn't find one. I was never invited to give a speech like this. So that's why I appreciate you guys doing that. Again, this extension circular, I've written it in layman's terms. It's not that technical. I think anybody will find it easy to read, and it gives all the details about how the project works, and with background information. And there's a glossary and things like that in it.
I'm gonna check the Q&A. It will come up for me. And then I think there was a question in here, but it says, what is the best way to test the water for a private well? Oh, yes. Thank you.
Yeah. So for testing a private well, so it could be good. So there's a couple different options, but sometimes your local natural resource district has some opportunities to test the well. I know that kind of working closely with the Department of Water, Energy, and Environment, they always recommend to get testing done by the Public Health Lab out of the Department of Health and Human Services. So they have a list of, I think, like 6 certified labs that are able to provide kind of different tests as well. So I hope that helps.
Yeah, thank
Thanks.
you. And then I actually had another question that I thought of for Erin that some people might be thinking too. Um, if if like the city of Lincoln or like the city of Omaha, for example, have a separate sewer system that's now supposed to clean the water, why is it important
It
for,
doesn't clean the
oh,
water.
it doesn't clean it.
Yeah.
It's just, it keeps it separate?
Yes. So Omaha has some old parts of town that are a combined sewer system. So water in that type of system is both sanitary sewer and stormwater. And so when there's low flows, it's fine, everything's fine. You get a high flow and then you have an overflow, and then that's how you get sanitary sewage into a stream or river. And so a lot of cities, including Omaha, have been spending lots and lots of money to separate. So if you're in Omaha, Spring Lake Park is a really big example of where they disconnected part of the combined sewer system and they diverted the stormwater over into the park and recreated the lake there. So Lincoln never had that. We were always separate. So we don't have that problem.
So that kind of talks about like the importance of reducing the amount of water, but I guess for enticing people to keep the water that's running off clean, like not washing your vehicle in the driveway and such. Since it's kept separately, like what's the importance of it? Like, is it still, it is still ending up in the waterways
It
and
is.
causing ponds to,
It's more of a mentality when they were designing the systems of getting the water as far away as possible, as quickly as possible, because they wanted to avoid flooding. When you have all this impervious area, there's nowhere for the water to go. So they create these storm drain systems to take the water away. And so then it just goes directly to a water body, so a stream or lake or pond or whatever that might be. But yeah, that's the what the mindset was behind it, if that helps.
yeah, thank you.
Yeah.
All right. I'm just going to double check to see if there are any other questions in the chat. Q&A, no, okay. It looks like there's some other people that need to still fill out the survey. So if you wouldn't mind filling that out, that would be great. But I just want to thank you so much, Dr. Comfort, Anni Poetzl, and Erin Kubicek for sharing your time and expertise with us today. Thank you, Water Futures Partnership of Nebraska, for hosting the event. And thanks to everyone who joined online and joined in person. Have a great rest of your night. Thank you.